Alright, welcome back. In this video, we are going to look at exact differential equations. Exact differential equations. So, what is exact differential equation? When we talk about exact differential equation, what exactly are we talking about? That is, let's say if given that u is a function which is in terms of x and y, is a function of two variables. I hope you can see that. And that variable is x and y. Then its total differential is given by the expression du is going to be equal to the derivative of the partial derivative of u as respect to x, then the partial derivative of u plus the partial derivative of u as respect to y. Alright, so all that we are saying is that in the question you will be given a function of u which is in terms of x and y. So the only thing that you do is that you take the partial derivative of u as respect to x and the partial derivative of u as respect to y. Alright, so the only thing that you need to take note here is that when you are taking the partial derivative of u as respect to x, what do you do? When you are taking the partial derivative of u, let's say u is 2x plus y. What we do is that to take the partial derivative of u as respect to x, we differentiate as respect to x by holding y variable to be a constant. If I'm to be, you are writing down. All right, very good. It's not everything that I will be putting on board for you to copy. So you take the derivative as respect to x by holding y variable constant. So look at this. When you take the derivative of 2x as respect to x, what will you get? 2. Very good. Now we are saying that here we are holding y variable as a constant. So even though it's not a constant, but we are holding it as what? A constant. So when you differentiate y, which is so since you are holding y as a constant, when you differentiate a constant, you get 0. So here is plus 0. Alright, therefore the partial derivative of u as respect to x is going to be 2. Now, then we now move on to take the partial derivative of u as respect to x. Sorry, we are done with that. We are taking the partial derivative of u as respect to y. Here also, we differentiate as respect to y by holding x variable as a constant. By holding x variable as a constant. So now if this is a constant, don't forget, this 2 here is a constant already. And the 2, the x here, we are treating it as a constant. That means that when you take the derivative or the partial derivative as respect, of 2x as respect to y, you are going to get 0. Plus, take the partial derivative of this as respect to y, you get 1. So here we get 1. I hope it's clear now. Very good. So thank you. That is that for that. This just by the way, we are now going to solve questions. Here, I will just want you to know how to take the partial derivative in case you have forgotten it. So let's go and look at our first question. Determine the total differential of the following functions. Now don't forget that here we are saying that if given that u of xy is a function of two variables, then its total differential is given by the expression this. So whenever you are to find the total derivative or the total differential of a function, it means that you take the partial derivative of u as respect to x, then the partial derivative of u as respect to x, y. That is why I showed you how to do that. Very good. So, example, determine the total differential of the following function. Sorry, x squared plus y squared. How are we going to see it? Very good. All right, so let's solve that here. Now we can fill in the middle. Very good. So solutions. Oh, I would like to tackle the second one first. Don't worry, I know the reason why. The second one first. All right. So as I said, in the question, we have u of sy to be equal to x cubed plus y squared. And we have to find or determine the partial derivative. So the first thing to do is to take the partial derivative of u as respect to x. So we are going to differentiate this function by holding, please be careful, my plus one guy, be careful. Here, we are not to do implicit differentiation. Yeah, I know you are good in plus one, but here we are not to do implicit differentiation. But when you are taking the partial derivative of u as respect to s, you are going to hold the y variable as a constant. Be careful about that. Very good. So here you get 3x squared. So this, if this is a constant, everything is 0. So forget about it. Very good. Then we move on to the partial derivative of u as respect to y. In the same way, this is 0. So here will be 2y. 2y. Very good. What is the next thing? The next thing to do is to write it in the total derivative form. In the total derivative form. And you know that is, it's like when you differentiate this, you get du. Du is going to be equal to partial derivative as respect to x, then here will be dx plus partial derivative of u as respect to y, and here will be y. Very good. So we have gotten this and this, so you are only left to do substitution. So here we get du to be equal to, what is partial derivative of u as respect to is 3x squared. Put it inside of the brackets and bring dx here. Oh. What is partial derivative of u as respect to dy? 2y. Very good. You see how nicely it's done? Very good. So this is the total derivative of the function that we have there. Very good. So that's the final answer for the question 2. I would like you to pause the video and try on question 1 and the question You can pause the video. You can pause the video and do that. Alright. So let's go to question 3. Question 3. So you can pause the video and do that, and when you are done, then you come back and watch. Alright. So question 3, we have u function of x in terms of y, which is what? X, y. So du, or you can first go and find the partial derivative of u as respect to x. Now watch. We are holding y as a constant. Don't forget that if you are to differentiate 2x, this 2 is a constant. But when you differentiate 2x, you get 2. So the constant will be left. In the same way, it's critical but not all that critical. In the same way, if you were to differentiate sy by holding y as a constant, alright, you just close this one. When you differentiate x, what will you get? 1. So here you get 1 times y. This is not plus. This is not plus y. Then for that matter, you will say 1 plus 0. Because this is a constant. So when you differentiate, you get 0. But in this case, the x and the y is joined. So x, y. So here you just get 1 times. So 1 times y is 1. Let's move on. Partial derivative of u as respect to y. In this case also, definitely you have to know that the answer will be x. Because you are going to hold y as a constant. And when you differentiate y, you get 1. So that's that. Very good. So finally, then the u is going to be equal to partial derivative of u as respect to x, which is y dx plus s dy. Alright, so that's going to be the final answer for that. Question 1. Question 1. You can still pause the video and try on the question 1. Yes, that you have to be good in your calculus 1. It's not anything difficult. Alright, I hope you are done writing it. Oh, question 1. It's not difficult. S power 3. S power 3 y squared plus 2xy plus s squared. Alright. Very good. So we start partial derivative of u as respect to x. So we are going to hold y as a constant. Please watch very well. That's why I first said that let's go and solve question 2 and 3 before we come to the 1. So that you will know how to take the partial derivative of whether as respect to x or y when you have it in a product form, when they are multiplied. So here you close the y squared because you are treating y as a constant. Differentiate 3x to the power 3, what will you get? 3s squared. That is multiplying the coefficient. You know this from calculus 1. I don't need to worry myself. Multiply the power by the coefficient, which is 3. Subtract 1 from the power, which is 2. You know this already. So this is 3s squared. Then, since this is a constant, you leave it as such. Alright. So that is that. Plus, here, treating y as a constant, differentiate 2s, you get 2. So here we get 2y. So to be left with the constants, you see that to be left with the constants, plus, oh, this guy, 2s. Oh, this guy, 0, 0. Alright. Then we go for partial derivative of u as respect to y. Not this so, but from the question. Treat x as a constant. So you get 2y x to the power 3 plus what? So 2x plus 0, 2y. Very good. So finally we get du to be equal to partial derivative of u as respect to s is 3x squared y squared plus dx plus, if you don't bring the ds, you are wrong, plus the partial derivative of very good, very good, very good. So that is how we solve such question. Alright, so generally, the total derivative, is what we have there. Now, the total derivative, which is du, is a function of n, which is in terms of x and y dx, plus the function of n, which is in terms of x and y dy. So, looking at what we did here and here, we can now see that the function of n in terms of x and y will equal to 3x squared. And the function of n as respect to x and y will be equal to, hope you can tell me that. Very good. 2y. Very good. Very good. In the same way as to this, the function of n as respect to y is going to be this, which is 3x squared y squared plus 2y plus 2x. So this total derivative of u as respect to x represent the nsy. And the nsy, you see that one is attached with the y. So you get to represent it here. This is the y. So the one attached with it is the function of n as respect to x and y. So that is 2yx squared plus, x cubed plus 2x plus 2y. That's that. So that is the total derivative of that. All right, so in general, if the equation, in general, we are still defining what the exact differential equation is, and we will get there very soon. In general, if the equation m xy, which is the total derivative of u as respect to x dx plus is equal to 0. What we mean is that if, hope you know where this is coming from. What we mean is that this means when the function of u in terms of x and y is equal to 0, because this is equal to this, and now we are saying this is equal to 0. So we are saying the same way of by saying that the function of u in terms of x and y is equal to 0. In such that the left hand side is the total derivative of some function u, then we call msy dx plus nsy dy as an exact differential. So we are saying that we know that a total derivative is a function of u in terms of x and y being equal to this. So if the function of u in terms of x and y is equal to 0, then this left hand side is the exact differential. In fact, it's interesting. Is the exact differential equation. All right. Now, what does this mean? This means that the solution of this exact differential equation is given by the family of curves. What we are saying is that if this as respect to x and y is equal to 0, is equal to c, that means that this is given by the family of curves, where c can assume any variable. We know that here in calculus we use c to represent family of curves. All right. So, for example, hope you are taking a good note. For example, 2xy dx plus 3x squared y squared dy is equal to 0. Now, when this is equal to 0, then we see the left hand side of the equation as being the total derivative of the function. This left hand side, we see this only left hand side to be the total derivative of the function u x y to be equal to x squared y cubed. What we are saying is that when you take the partial derivative of u as respect to x, you get this, and definitely you get that. And when you take the partial derivative of this as respect to y, you are going to also get this. And when that happens, then we are saying that this is a total differential equation of this function. All right. But when we equate it to 0, like what we're having here, then we say that is an exact differential equation. So always don't forget that. Very good. Hence, the general solution of this equation, if you're looking for the general solution of this equation, is going to be x squared y cubed is equal to c. So when you equate E to C, that become the general solution of the differential equation. Very good, very good, very good. All right, so you can try on this. I hope it's clear. We are saying that when you set, I'm repeating again, when you set the function of u as respect to x and y to be equal to 0, this gives the exact differential equation. This means that this is an exact differential equation, whereby the left hand side, this, the total derivative of this is this, and this left hand side is the exact differential equation. And when you equate it to be equal to C, that is the general solution. That is the general solution. All right. So, for instance, if you have y dx plus s dy to be equal to 0. So, what is the left hand side? The left hand side, the left hand side will be what? The left hand side will be the equation. That is the total the total derivative of u of x and y, which is equal to s y. Because when you differentiate this as respect to x and as respect to y, that is going to give you this. Very good. Then, what is going to be the solution? The solution is going to be when we equate this to be equal to c. That is going to give us. Alright, so now what is then exact differential equation? About all what we have been looking at it so far, what is then exact differential equation? So it's an equation of the form this, alright? That is m in terms of x and y plus n in terms of x and y is equal to 0. Where the expression this is the total differential of some functions u, which is equal to u in terms of x and y, in a domain D, is called an exact differential equation. So that is the definition of an exact differential equation. And don't forget that whatever we have done so far is important as far as your journey to exact differential equation is concerned. So we will back in the next video to be looking at how to verify whether an equation in this form is an exact differential equation or not exact differential equation. Also, remember that this topic, that is exact differential equation, is also part of the techniques in solving a differential equation question. The first one that we look at is a separable differential equation. The second one is a homogeneous differential equation and equation visible to homogeneous equation. And now we are at exact differential equation. In fact, you will have to see you in the next video. Until then, know that you are loved.